This is a demo flight in the AS33 glider. Link for that glider will be in the comments. And it's specifically about flying a short task that's got multiple waypoints with a flight plan. And the comments to make is to load the flight plan. Microsoft obviously doesn't put things in the flight plan that particularly help soaring flights. But the instrument in the AS33 allows you to do a couple of things that just make things a little bit better. So when you create a flight plan here, we have got LOWZ, a couple of intermediate waypoints, and then Langkampfen Airport, all in Austria. It's a 69-kilometer flight. If you make the name of the waypoint anything that's got a plus followed by a number, the nav instrument that's in the AS33, and it's going to be in other gliders as well, will interpret that number as you saying this is the elevation of that particular waypoint. There's no other way of doing it in Microsoft flight plans to actually get this elevation read from the flight plan and displayed in the instrument. It's just Microsoft's just not designed for that. Okay, so if you, instead of just calling it WP1 when you click and add a waypoint, you call it WP1 plus, and then 6170 is the altitude. To look it up, that is the altitude in feet of that waypoint. I did the same thing for waypoint 2. This task, by the way, comes from Chris Bullis. There's another thing, that the flight plan understandably has multiple waypoints in it. It isn't obvious from the flight plan which of those waypoints do you want to be the start waypoint and which of those waypoints do you want to be the finish waypoint of the task. Obviously, you're going to take off somewhere, obviously you're going to land somewhere. That doesn't tell you completely, but is the actual start point one of these intermediate waypoints? And the same could also be true of the finish point. Again, there's no way of telling Microsoft Flight Simulator that's what you mean. So if you begin the name of the waypoint with an asterisk, then the instrument, the nav instrument that's in the AS33 will know you're saying that is either the start point, the first one with start point, the next one with an asterisk will be the finish point. It's just kind of convenient. You don't have to do either of those things, right? If you just name the waypoint WP1, it'll work fine, and the instrument will use it. It's just the fact is, it won't know the altitude of that waypoint. So your final glide calculations, or your glide calculations relative to that waypoint, will have to be in feet MSL, mean sea level. It can't be relative to the height of that waypoint, because Microsoft Flight Simulator itself does not know what the height of that waypoint is. Unless you tell it by going plus on the end of the name of the waypoint. Okay, so looking at the task in a bit more detail, the wind that we're expecting to be set for this waypoint is 14 knots from 230 degrees. And just illustrating that on the map, and I've drawn it 3 times, is when you're flying this leg, the wind's coming from that way. When you're flying that leg, the wind is coming from that way. And when you're flying that leg, the wind is coming from the same direction. But you have to look carefully and work out, well, okay, which ridges are going to be working if I'm trying to get from there to there? And Chris has designed this task carefully, and conveniently, this valley slope is about 6,000–7,000 feet high at mean sea level. The base of this valley is at 2,500 feet or so. That's facing mostly into this, partially into this wind, more so as you go around the corner. Then clearly, as you're taking this leg, you're going to be using the slopes on this side of the valley, because they're the ones that are going to catch the wind and cause an updraft. And when you're crossing to this last leg, then you're going to be north on the south-facing slopes, i.e. the into-wind-facing slopes, is where the lift is going to be. Okay, so we'll keep that in mind. And then the last thing to check when you start a flight, and particularly when you create one, I'm not talking about how did you create this flight in the first place, particularly in this talk, like using LittleNavMap or Plan G or Microsoft Flight Simulator itself, is you look at the alignment of the runway you're going to take off from and the runway you're going to land at. And I've illustrated those with red arrows here. And you can see in both cases, we'll make sure this flight starts with you on the right end of this runway, i.e. you want to be facing roughly southwest, because you're going to take off into wind. And the destination airport has the runway aligned diagonally in this way, so understandably we're going to want to come in, turn left and land so that we're landing into wind. But you've got to keep that in mind. There is a wind instrument in the glider that will tell you. Okay, so with that, let's get in and fly. Right, here I am in the AS33. If you look at the nav panel, there's the LOWZ to Langkampfen Airport task on it. And we can look at the task page. See this button down the bottom. Okay, LOWZ, there's a waypoint called start, which this nav panel is correctly identified as, or chosen as the start waypoint. We could have changed it. By the way, if we want to change it, it's just a case of scrolling through the waypoints. You want to be the start and then clicking. There you go. So I just made LOWZ the start. If I scroll down to start, click, it's made start the start. These are just the names of the waypoints. And it's saying waypoint 2 is the finish because it's kind of guessing if you've got a launch airport, a final airport, and then the waypoint, the finish would be the waypoint just before the final airport. That's wrong in this case, and the way you change that is slightly different than just clicking anywhere you want to make it the start. You actually click on the finish, the currently selected finish, which is that one, and then, as it says, select a new by scrolling waypoint, click, and it'll make that the finish. Okay, so now I've got the waypoint called start is the start, waypoint called finish is the finish. And this affects things like the way whether you started or not is calculated, and the timer and your task speeds. They've got to be relative to those two waypoints, and there isn't an easy answer for this instrument to know which instrument should you pick. It has a pretty good guess, right? Even if you haven't done any of the fancy markup I told you with an asterisk to say here's the start or a plus to put the heights in, it will do something. This time though, it's getting the heights correct. And even though it says the start, that is a waypoint at 6,230 feet. If we go back here, you can see it's drawing, that's that waypoint there, it's drawing the start line on it. So I'll scroll back up and choose start as my current waypoint. That's what we want, because that means it will trigger when I cross it, and then it'll automatically switch over to next. So see this yellow highlighted start line, I can cross through that anywhere. So I'm not actually going to go up to 6,230 feet. I did the first time I tried this task, but then you've got enough height to blitz around this task going absolutely flat out until you get to the end, which wasn't ideal. So what I'm going to do is do it slightly differently, take a slightly lower launch. I'm going to launch 2,500 feet above the airfield, and we're currently at 2,500 feet. So I'm going to take a motor start up to 5,000 feet and then head off from there. Okay, so with that, I'll just show you where the start is if we go outside. So here we are. The wind is coming from our left across to our right, more or less. So headwind there's pretty serious headwind as well, actually, on this leg. And that start waypoint is up the top here somewhere. But it has that perpendicular line coming out across crossways, and we're just going to fly through it this way. And I'm going to try not to fly it through that line before I've got 5,000 feet. Okay, so off we go. Let's have a look. Let's get ready. Power up the engine management panel. Open the raise the pylon. We're carrying full ballast, by the way. You're going to see that at the end if I remember to dump it, which I didn't do last time I tried this flight. We've got the headwind coming down. Controls, flaps, speed, instruments, trim, canopy. Start the engine. Putting the brakes on, I should have done it first. Let the revs build up. Let's zoom in a bit on here. And off we go. Level the wings. The wind is coming from our left, so we've got a tendency to weathercock to the left. counterintuitively, I'm starting slightly to the right. That's just the way the glider was pointing when we started. So now the glider's trying to weathercock to the left a little bit. Up we go. Gear up. Ooh, flying way too slow. I wasn't paying attention at all. Okay, so I'm going to climb to 5,000 feet. There's the airport we took off from. There's LOWZ down there. This flight, as I mentioned on the map, was by Chris Bullis. I think it's quite a picturesque trip. It's quite short, it's 69 kilometres, so it shouldn't take us long. The first bit will be slower because we'll be gaining height on the ridge as we fly along this valley, you can see now. But then we're going to speed up after that. 4,500 feet, I'll do 500 more feet, just to have a sort of sensible start height without going too high. So 2,500 feet above the ground. There we go, engine off. When the revs go to 0. There we go. Put the engine away. You can see it's being displayed on this graphic down the bottom here on the engine management gauge. You can see the engine going away there. Okay, and we're off. So I haven't started yet, and if I'll send to the plane and zoom in, there's the start line, which I can cross anywhere through this start line. This task doesn't particularly have an assigned start height, minimum or maximum. And now, pointing along the valley, you can see the direction the wind is in, from diagonally to our left, from our left, I should say. What it means is these gullies to our right will get ridge lift just this side of the hill here, and then we'll probably just get sink just the other side of it because of the wind curling over the top of that ridge. But overall, I'm not too worried. I think there should be sink around here. Not much. No, there is. There you go. See it? It doesn't sound as bad because I've turned the audio sound for sync off on the very. There's the happy sound. I'm just going to turn up the McCready setting to set the speed I'm telling the computer I'm going to fly at. There you go, I've set it to 4 knots. Which is reasonably, that's a sort of medium setting. It would be strongish, reasonably strong in the UK, but not particularly strong in warmer places. So we did the start, by the way. I wasn't even paying attention. And off we go. So the start timer has started. We were going 55 seconds ago. It must have started. And this box down the bottom here saying 90 at the moment is telling us our cross-country speed achieved on the task. So if we deviate from the direct route, obviously the speed, our task speed is going to go down, as it is, fairly radically. Yeah, obviously the impact of that is much higher at the beginning, then we'll be halfway around. So we haven't lost any height yet, we're still at the same 5,000 feet we started at. Okay, that's basically unsuccessful. It's trying to get a bit of lift on that ridge. You can see me changing the flaps. Basically the flaps just go exactly with whatever speed you're flying at. And A, 0, -1, -2. That's you flying faster and faster. So -2 is too negative a flap setting for the speed we're flying. You wouldn't be using -2 until you're doing, say, 90 knots. Then it would be the most efficient flap setting for that speed. Below 90 knots, down to, I don't know what, 80 knots, 75 knots, you'd be in -1. Below that, you'd be in 0. And then for normal, just straight flying, you wouldn't go below 0. In fact, it probably wouldn't go below -1. You know, -2, -1, 0 for straight ahead flying. When you turn and circle, then it's not just about absolute glide performance. It's also about how slowly can you fly without stalling, so that you can turn tightly in thermals and that kind of thing. So then those positive flap settings. Okay, this sucks. Oh, I mean, I've got to be in sync here, surely. The netto is not too. This is pretty bad. I shouldn't be here. I'm now flying down the slope at the back, not getting enough height to get over this. So I should speed up. Is really what I should do. Oh, this is awful. Okay, so I'm flying fast enough now that I'm going to get over it. I think that probably cost me I wasn't paying attention, but I think it probably cost me 300 feet. There we go, straight into the headwind. So you don't really want to be slow when you're so close to the ground, because the slightest loss of lift, you'll drop 50 feet and hit the ground. So, you know, which is not particularly a good thing. Okay, I'm optimistic about this. to stay this side instead of going over, because there's sink just the other sides of these little gullies. Well, I got my 300 feet back. Just coming in from the left-hand side of the nav panel, that's a 10-kilometer range ring for waypoint 1. And this time I do need to get up to that height, so I'm currently 2,500 feet underneath it in terms of arrival height. I've got to get up there because there's a proper turn point, so I've got to get within 500 meters of it, unlike the start, which is a line. So I'm going to have to start flying slowly and get as much lift as I can. Anybody could legitimately criticize this flying because I'm taking way more risks. You'll see on things like the glide, I'll be conservative and then we're going to get there too high when we get there and things like that. Because I do generally fly conservatively. But like flying up that gully and then turning around at the end, you wouldn't even think about doing that in a real glide. It was just too close to the limit. Okay, so now we're 1,400 feet underneath the waypoint. in terms of arrival height, 1500 feet. .73 kilometre cross-country speed, kmh. It's pretty atrocious. It's worth it going up there just for the lift. Dangerous, but worth it. So we're 1,000 feet below the waypoint. This is the best slope we've had so far. See, that wind is now pretty much sideways onto this. Well, better than it has been anyway. Well, I was expecting it to be better. I don't know if I'll post this video, the flying is so risky. But the whole point of it was to demonstrate this nav panel, really. Phew, made it. Okay, so it's flipped over to waypoint 2. It's saying we've already got that one made from here. And if I do an interesting thing here, we're only showing one waypoint, waypoint 2. This gauge can show arrival heights. Hang on a sec, let's just see what's going on outside. And we're okay. That's what I meant. This gauge can show us arrival height around as many waypoints as you like. So if this knob on the bottom left just controls the display, it controls how many waypoints are displaying here. So many instruments could only show you one. Many instruments you don't get the arrival height. This is calculating the arrival height. These two numbers down here, by the way, are the glide slope you need to get to the waypoints and the glide slope we're currently doing. So if we glide at 36 to 1, this glider has a still air max glide ratio of 56 to 1, so better than that. Then we would make the waypoint. And this plus 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 means our current glide ratio is infinite. In other words, we're not actually sinking at all. You can see by this Netto Vario particularly, or this average, we're actually going up at about a knot. Yeah, so you see our glide ratio will be going up and down all over the place. Okay, but if I scroll up and show one more waypoint, this is showing not only do we get to our waypoint 2, 300 feet now above that waypoint, but we will actually, when we round that waypoint, I can show on the map, I'll zoom out. Maybe I'll leave that like this now. Yeah, we're going to get going around the first waypoint, 20 kilometers to this coming waypoint, which is got the wind right behind us, so that'll be quite an efficient flight. Plus the wind is giving us ridge lift off this ridge to the right as well, so we're going to do great going down this leg. And then we're going to turn, the instrument is expecting us to have an 8 knot headwind, and we'll go up here, turn left, and that's where the finish line is. You can see the finish line, if you can just make it out, drawn as a small perpendicular line there. But we can afford to speed up now, because we've kind of got it made. There is a little bit of high ground between us and the turn point, so we can't have an arrival height that goes down. I guess you wouldn't be guessing in a real flight, you know exactly what the figure is, but I'm guessing we need, and I hope I get this right, an extra 1,000 feet just to get over a bit of high ground that's in front of it. We'll see. Okay, but we can scoot along now. So our cross-country speed is 90 kilometers an hour. We'll see what it is by the time we get there. And we've been flying for 20 minutes and 49 seconds. By cross-country speed, I mean task speed, which is the achieved distance on the task minus how, divided by how long you've been flying. We're going to get ridge lift on that east-west route, we're going to get ridge lift on that as well. Remember the wind direction. So basically, I'm flying now, keeping the arrival height at the final waypoint round about 1,000 feet. If it goes too low, I'll slow up a little bit. And hope I've calculated 1,000 feet well enough. And you know, this figure here is dependent upon the speed I've told this whole computerized panel, the speed I'm going to fly at, which I did via this MacCready knob. Okay, so here's our last bit of hill. I'm actually going to use the front side of this ridge just to maximise the energy we get. Okay, so definitely credit to Chris Bullis, who created this task. It really is quite a scenic trip, really. Can you see the direction indicator now in the center of this dial has got me pointing, oops, oh no, the speed, got me pointing straight at the waypoint. So we're going for it. Still with 1,200 feet above the final waypoint. When we go through waypoint 2, you'll see the display area that's actually taken up. Even though we've set, the gauge will remember from one time to the next how many waypoints do you want displayed on the normal flight screen, which is what we're looking at now. When you've only got one waypoint left, then the whole thing can shrink down a little bit. You know, obviously there's no point in showing you two when there's only one left to go in the task. It will just show that one, so you'll see it in 5 kilometers time. You'll see it shrink and give us more map real estate. Okay, so we're doing fine here. We've still got 1,200 feet arrival height, if that's enough. That was my calculation. Not my calculation, that's my guess. There we go, we'll be going across that one. .7 kilometers to go. This leg we've got a 7 knot tailwind, which is great. And then we'll have, what will we have? We'll have 22 kilometers to go. The ballast, the pilot's handbook says it could take 4 minutes to dump. There we go, waypoint 2, okay. And it's clicked over to the next waypoint, which is the Finnish Landkampen Airport. And we're going along by these ridges here. I think when we've got 16 kilometers to go, I'm going to dump the ballast. And Brett, who is the modeler of Modolo plus B21 on the B21 half, he hasn't seen the ballast dump effect yet, so he might see it for the first time on this video. Okay, 1,850 feet, we've got sort of an embarrassment of height. But be careful, I leave enough time. Okay, I'm going to start dumping the ballast. There's the dump effect. Got a slight B-52 look to it. You see, there is the outer tanks, the tail tank, and then the 2 inner tanks. The largest tanks are the 2 inner tanks for good reason, and the tail tank always empties first because you avoid ending up in a tail heavy situation, which would be a nightmare. So you'll see the tail tank stop dumping shortly, I think. There you go, it's tail tank stop dumping. I'm not very good at flying other than first person. I'm actually climbing at the moment. Just going to check we're going the right way. Yeah, more or less. Oh, let's see how much height we've got. 2,300 feet. See, I slowed up because I'm driving from the outside, isn't something I'm particularly used to. Right, we're going to see the tail tanks. The outers stop dumping very shortly. There you go, leaving us just the inners still emptying. You can see from this ballast gauge here what's been going on. You know, that's the tail tank. These are the two outers, and then those are the two hoops overspeeding. .145 knots is the max, 270 kilometers an hour. See, this was the high ground just here that I was aware of. Yeah, good. So the ballast is dumped. So high speed performance is suffered. The gauge knows how much ballast is on board. So it's adjusting things to take that into account, adjusting what it's telling us, taking that into account. Yeah, that's the airfield there. Let's say finish in a second. There we go, task completed at 15:42 local time. Water, undercarriage, flaps. There's the airfield down there. Not the easiest one to spot. We'll have a wind straight down the runway. there's the airfield. We're considerably above it, I think. I'm opening the air brakes. Yeah, there's the runway. Easy. There we go. So let's just look at the task page. There you go. So this green bar up here, task completed. 69.3 kilometers is the length of the task. We completed it in 30 minutes, 44 seconds at an average speed of 135.3 kilometers per hour. And these OKs are confirming that we went through each of those waypoints successfully. And this is actually telling us our individual leg speed. You can see how slow we were and dangerous. Okay, I think I'll publish this video, but it's pretty outrageous. We managed 80 kilometers an hour on that first leg. And then after that, it was a romp home, especially the last leg. There we are. So Chris, thanks very much. It's a nice flight.